Hello and welcome back guys to another Alpha Math video. In this lesson, we'll be focusing on sigma notation. Now sigma is the funny symbol that we're looking at in blue over here, and it's a Greek letter. Okay, in fact, it's the letter S in Greek. What it stands for is to find the sum of a certain amount of things, okay? So it might be terms in a sequence or whatever. For example number 1, we have the sum of the first 8 terms of the pattern 3n minus 1. So notice how I read that. The sigma letter I read as the sum of. The n equal to 1 I read as the term where we'll start adding. And 8 was the term we were going to end at. 3n minus 1 was the formula for the pattern. Okay, so let me read it again. The sum of the first 8 terms of the pattern 3n minus 1. Okay, so let's start out by writing out the first 3 terms of this pattern so that we can get a better feel for the pattern. Okay, now term number 1 would be 3 times 1 minus 1. And that's just equal to 2. Then term number 2 would be 3 times 2 minus 1, and that's equal to 5. Then term number 3 is 3 times 3 minus 1, and that's equal to 8. So we have 2, 5, and 8. The constant difference between these terms is 3, okay? Because we add 3 to progress to the next term. Right, now to find the sum of the first 8 terms, I want to make use of a formula that we are well familiar with. This is the sum formula for an arithmetic pattern. All you need to do is substitute a with your first term. So remember, a is the 2, the first term. And substitute d with the difference. D is 3. And remember they said find the sum to the first 8 terms. So n would be 8. Let's simplify this a little further. So we get 8 over 2, which is 4, and 2 times 2, which is also 4. 8 minus 1 is 7, and 7 times 3 is 21. Okay, once we add the 21 to the 4, that should give us 25. Multiply that by 4, and it's exactly equal to 100. So your answer is 100. So what we did now is we calculated this expression to be equal to 100. Moving on then to a second example. For this one, you need to be careful how you read it, because we are not looking for the sum of the first 9 terms, but rather we'll be starting from the 4th term. And so we start adding from the 4th term all the way to the 9th term. So that means excluding the 1st, 2nd, and 3rd term, which means we'll only be adding 6 terms in total because we're excluding the 1st, 2nd, and 3rd, right? Starting at the 4th term, ending at the 9th term, and then also the pattern that we are given here is a geometric pattern. So I'll need to first work out the 4th term and the 5th term of this geometric pattern so that we can properly identify where to start and also what the ratio will be. Right, so let's begin by calculating the 4th term. Okay, we'll do that by saying half to the power of 4 minus 4. You are substituting the starting point, which is 4. Okay, so 4 minus 4 is a half to the power of 0, which is simply equal to 1. So the starting point is now 1, right? That's term number 4. We need to work out term number 5 by going through the same routine, but this time substituting n with 5. Okay, and this becomes a half to the power of negative 1, which is equal to 2. Okay, now 2 terms is enough to identify a ratio, but we are just going to calculate another term so term number 6, just to make sure that this is in fact a geometric pattern. Right, so we'll say a half to the power of 4 minus 6, and that is equal to a half to the power of negative 2, which is equal to 4. Okay, so you can now clearly see that this is a geometrical pattern, right? And the ratio is that we are multiplying by 2 each time. Our first term is 1, that's A, and our ratio is 2. So now we can straight up make use of our sum formula. We are going to be using a different sum formula as this is a different pattern. We'll be making use of the formula A times r to the power of n minus 1 divided by r minus 1. Okay, now substitute our values. The first term of this pattern is just 1, the ratio is 2, and the number of terms, let's look at this one more time. So we're starting from the 4th term and we're ending at the 9th term. So 4, 5, 6, 7, 8, 9, that is 6 terms. Okay, remember the only 3 terms you're excluding is the 1st, 2nd, and 3rd term because you're starting at the 4th term, right? Including the 4th term and the 9th term. So therefore n is 6, right? In fact, I've seen a nice formula for this. When looking at the sigma notation, if you want to know what n is equal to, just take the top number, minus it from the bottom number, and then add 1 to that. Okay, so 9 minus 4 is 5, add 1 gives you 6. Okay, now let's plug this into our calculator, or I guess we could simplify this by hand as well. 2 to the power of 6 is 64. Then we're going to subtract 1 and then divide by 1. And so that's just equal to 63. Okay, that tells us that the answer to this expression over here, the answer to this is 63. And now finally, example number 3. Okay, so here we have a sum to infinity. Notice there's an infinity symbol at the top. So we're going to find the sum to infinity of this sequence over here, 6 times half to the power of n minus 2. Let's start by calculating our first 3 terms of this infinite series. Okay, so if we substitute 1 with the n value over there, and I guess I can do the calculation over here. We'll say 6 times a half. Now substitute n with 1 minus 2. Okay, we can simplify this. That will be 6 to the power of, or rather 6 times a half to the power of negative 1, which simplifies also to 6 to the power of, or rather 6 times 2, and then that is equal to 12. Okay, so quite the procedure, but eventually we understand here that our first term is equal to 12. Okay, if you go ahead and substitute now n with 2, 6 times a half to the power of 2 minus 2, again 2 minus 2 is 0, so we have a half to the power of 0, which is equal to 1, and then I guess that just gives us 6. So term number 2 is equal to 6. And I'm not going to do the procedure again, but I guess by inspection we can estimate that term number 3 is going to be 3, because following this ratio of halving the terms means that the next one is going to be 3. To find the sum to infinity, we'll make use of the sum to infinity formula of a geometrical pattern, and that is a over 1 minus r. So substitute a with your first term, and that is 12. Also substitute r with the ratio, which is 1 over 2, a half, and this should simplify to 24. Okay, so if you simplify this, the answer is 24. which implies that the answer to this series expressed in sigma notation is equal to 24.